Today we are going to look at binomial expansion, which is of course a method for expanding binomials. It is very useful when we come across binomials with higher powers than 2 or 3, for instance 7, 8 or even 20. A binomial takes the form a plus b, and we're going to raise it to the power n, where n is a positive integer. A binomial is simply a polynomial with two terms, and a polynomial is an expression like this: 4x to the power 5 minus 6x cubed plus x squared minus 5x plus 2, for example, where except for the constant, the 2 in this example, all terms have a variable raised to a positive integer power. The degree of a polynomial is its highest power of x. In this example, the degree of the polynomial is 5. So you know how to square a polynomial, like a plus b. So we square a polynomial, we have a plus b, all squared, and we know this is equal to a squared plus 2ab plus b squared. We already know that. But what happens if we are asked to expand a plus b to the power 7? Of course, using our usual way would be tricky, tedious, and pretty much pointless. However, the binomial theorem is here to assist us for these confusing problems. The important formula you will need to know to tackle these harder problems is this one. So we have a binomial, a plus b, and we raise it to the power n. The formula goes like this. We take the sum as k equals 0 to n of n choose k times a to the power n minus k times b to the k. So this is the important formula here. So don't worry, I'll explain what this means. So this here, nk with brackets, is pronounced n choose k, and this is equal to n factorial divided by k factorial times n minus k factorial. So don't worry, it will make sense in a minute. And n choose k can be written as nc. Oh, you might have seen that before. So let's do an example. So get rid of that page. And this example will just be an easier one. It's going to be x plus 4 to the power 5. So if we use the formula, it can be written as the sum of k equals 0 to n, where n is 5, of 5 choose k times x to the power 5 minus k times 4 to the k, whereby we substituted our values into the definition. So therefore, 5k, or 5 choose k, can be written as 5 factorial divided by k factorial times 5 minus k factorial. Okay? And one important note is that 0 factorial is equal to 1. That's really important, so make sure you remember that. 0 factorial is 1. Don't ask me why, it just is. So first we will calculate n choose k from k equals 0 to k equals 5, which the summation told us to do. So let's do that. So we're going to go to, first of all, 5 choose 0 because k starts at 0. So this is going to equal 5 factorial divided by 0 factorial times 5 minus 0 factorial, and this is equal to 1. So that's 5 choose 0 is equal to 1. Now we do 5 choose 1. This is going to equal 5 factorial divided by 1 factorial times 4 factorial, and this is equal to 5. Next we do 5 choose 2. This is going to equal 5 factorial divided by 2 factorial times 3 factorial, and this is equal to 10. Next we do 5 choose 3. It's going to equal 5 factorial like normal divided by 3 factorial times 2 factorial, and this is going to equal 10 as well. And then we have 5 choose 4. This is going to equal 5 factorial divided by 4 factorial times 1 factorial, and this is equal to 5. So we can see a pattern here, and I'm going to guess that the last one, 5 choose 5, is going to equal 5 factorial divided by 5 factorial times 0 factorial, which is 1. Therefore this is going to equal 1. So we've got a nice pattern there. So now that we have done that, we can calculate the rest of the sum. So I'll leave that there. So x plus 4, sorry, to the power of 5. So this is going to equal 5 choose 0. So we're just using the formula. Remember, it's a sum, so you can write it in this form. X to the power of 5 times 4 to the 0. If you've forgotten the formula, just go back and I'll show you. Plus 5 choose 1 times x to the 4 multiplied by 4 to the 1. Then we add 5 choose 2. This is going to equal x cubed times 4 squared. We add 5 choose 3 multiplied by x squared. Did I find equals there? I don't know why I did that. Sorry. 5 choose 2 times x cubed. Then 5 choose 3 times x squared multiplied by 4 cubed. And then we add 5 choose 4 multiplied by x to the 1 times 4 to the power of 4. And then finally we add 5 choose 5 times x to the 0, which is just 1, times 4 to the power of 5. So that's it in expanded form. So which, when we simplify and substitute, we are left with this. X to the power of 5 plus 20x to the 4th plus 160 x cubed plus 640 x squared plus 1280 times x, and then add the last term, which is just 1028. So there you have it. In part 2, we will find a quick and easy method to solve n choose k by means of Pascal's triangle and implement that into another example. So I'll see you in part 2.